Hello everybody and welcome back to another coding tutorial video. You guys really enjoyed the first one, so I'm going to keep on doing these, and we're actually going to do 2 of them a week. On Tuesdays, we're going to do something that explains a main topic, a main big topic of Python, and then on Sundays, we're going to use that topic and do something cool with it. So today, obviously it is indeed Tuesday, we're going to be learning about functions. And functions are pretty dang important in Python and really in any coding language that uses functions as its primary source of doing things within the code. So we're going to look a little bit into what you can do with functions, why you should use functions, and also look at some cool things you can do in Python using a software called Turtle. Or a library called Turtle that you may have actually known from Minecraft. We'll talk about that in this video. It might be a little longer video because we got to explain a bunch of different stuff, but that is a-okay. We'll make it happen. Let's hop right in. So here we are. We're in our PyCharm window here. And you know what? Let me just close this out so I can show you guys exactly how to do this. We're in PyCharm that I told you to download in the last video. If you haven't seen the last video, go watch that first, as that will help out a lot more here. But since we are coding in Python, I figured we might as well use PyCharm as our IDE. So just make a new project. We can do a file new project. You can't see this right now because of the way that my recording software is set up, but just create that new project and then we'll have it right here. Right click, new Python file. We will name it function since that's what we're worried about today. And then there we have a nice little text prompt ready to go. So as I said at the beginning, there's 2 main kinds of languages in code. You have procedural languages and then you have object-oriented languages. Okay, so what is the difference between these two? Procedural languages, just type this again here. These are languages like C, Python, C++, C#, Lua, for those of you that are into Isaac modding and other game-related code. These are all procedural languages. This means that they primarily use functions as their way of doing stuff. Or object-oriented languages, I probably should have kept this stuff in here. I'll keep that in there. Object-oriented languages are languages that use methods stored inside of objects or classes in order to do all of its work in the code. I'm not going to get too far into object-oriented languages. I personally find them to be a bit more confusing than procedural languages. And if you're here trying to learn functions, you don't need to know object-oriented language yet. Let's start with functions and work our way from there. But the one language that primarily uses object-oriented setup is Java. And many of you know Java, you've heard of Java, and many of you may know that Minecraft is coded in Java, which is not necessarily a good thing, and we're not going to get into why in this video, but maybe in a future video I can talk about why Minecraft should not be coded in Java. But anyway, these are your 2 main types of coding languages, procedural and object-oriented, and obviously we're going to be looking at Python, which is a procedural language, so we're going to be working with functions. Okay, so what is a function? Many of you that have taken a math course, an upper-level math course, either Algebra 1, pre-algebra probably even covers this at this point, you would know that a function is usually y equals and then some variable x and then manipulating it in some way. Plus 3 or divided by 3 or times 3. You know, this could be 3x right here. It's essentially you put in something, you get out something. So if we have y equals x plus 1 and we have we say that this y is a function of x and we put in 1, then this is going to be 1 plus 1. So this function, when you plug in 1, is going to be equal to 2. This is how math functions work. Surprisingly, or not so surprisingly, this is also how functions work in code. You put something in, you get something out. Now, this does not mean that it's a one-to-one function, which I'm not going to get too in depth into different kinds of functions, but essentially in code, you're allowed to have the output be the same depending on a different variable you put in. So say that we have y equals x squared, okay? Say we put, and we'll make y a function of x again. Say that we do y of -2, okay? This means that this x is going to be -2, and -2 squared is equal to 4. We can also have y of 2, which is going to be equal to 2 raised to the 2, which is also equal to 4. So you can have the same outcome by putting in a different thing. And that's kind of important in code functions, because there are a lot of times where one of the main reasons why you should even use a function is the reusability of that function. You want to be able to use it for a bunch of different things, even if those things are the same. Even if you're getting the same outcome. You never want to hard code in numbers for certain things, because you want to be able to use that code for a lot of different stuff going on. And we'll kind of explain more. I know it's a very shady definition that I just said right there, but it'll make sense when we actually start setting up code in here. Before you ask, why should we use functions? In the last video, we did not set up any functions. We just said, x is equal to 1. Let's comment this stuff out here. We just typed in x is equal to 1, and then print x, and then also print, x plus 2. There's no functions here. We did not put in any functions into this program, but it still ran. It still did what it was supposed to, and it went in order of everything here. Why should I use functions? Well, when you're doing just 3 lines of code in a program, then yeah, I suppose you don't really need a function. But when you're doing high-level coding, you're going to have hundreds, even thousands of lines of code in your program, and functions allow for readability. It allows you to know where stuff is. You can split up certain things depending on the function. It also, as I said, allows you to reuse things. Reusability and readability are the 2 main reasons to use functions. So I'm just going to write this down here. Reusability and readability. Both 2 insanely important things here. And we'll just comment those out so that our compiler doesn't yell at us here in a little bit. So let's make a function in Python. And there's a couple of important things that we should know before we even do this. In Python, and this is one of the only languages that does this, whitespace is very important. Whitespace depends, it controls how you do things. If we were to say, x equals 1, and then here do a tab, and then x equals 1, this is actually, and it's actually going to yell at me here because we're using the same variable. If we do a tab, y equals 1, then this is not actually syntactically correct in Python, because we have this useless whitespace here. It expects there to be something before this that makes a difference, such as, say, an if statement. So if x is equal to 1, then y is equal to 1. If we have this back here, this is going to be syntactically incorrect, because now this if statement is not seeing this y equals 1. So this is the same with functions. And you define a function as so. Def for define, and then the name of our function, we'll just call it name for right now, and then an open and close parenthesis followed by a colon. And that is literally it. That's all you need to define a function. So right now we have a function called name that's taking in no parameters. We can put parameters in here, and we'll talk about that shortly, but we don't need to right now. So we got name right here, and then we'll hit return, and PyCharm automatically indents for you, so it does that white space, but keep in mind you will need to do it. You can't then start typing the code for your function here. You gotta bump it over to here and start typing here. So define name. What do we want to do in our function? We want to print hello world, okay? Or hello world. There you go. A nice hello world. Kyrie Irving's favorite thing here. So there's our function. Define name, print hello world, okay? And then we're now out of the function because we are no longer indented. Let's just call name, okay? So we have our function defined as name, and in our function we're printing hello world. Do not actually, I'm typing in C right now. We do not need the /n at the end of that. I'm very sorry. And then here's name. We're going to call that function. So this is going to do exactly what you think it would, except for the fact that it yelled at me because I'm still trying to run last time's file, so just give me 1 second here. I'll change this to functions, apply, and now we can run it. And it did nothing. Okay, don't worry too much about that. It was just a little bit of inside baseball stuff. When we do run our code, we do get it to print out hello world, as we do call this function, and it prints it right here just as so. No issues whatsoever. So this is a very basic function. We only have it doing one thing. We're just printing hello world. Not very exciting in the slightest. Let's make something a little bit more exciting. Let's create a function that adds 1 to something that we pass in. Okay, this is going to show us how to use parameters. So we're going to have our function name as add, and then we're going to add a parameter in here. And we're just going to call that parameter the thing to add to. This is a very long variable name, but that is okay, as it'll help you understand exactly what's going on here. So we have a function, add, and add is expecting us to pass in thing to add to. Okay, and in here we're just going to say that thing to add to plus equals 1. And we used plus equals in the last video. This basically just means thing to add to is equal to thing to add to plus 1. Okay, and we can write it like that as well. I'm a-okay doing that. So now when we call this function, we have to do this. So x is equal to, we'll just create a variable x, we'll make it equal to 10, and then we will call the add function, and we will put x inside of our add function. Keep in mind, this does not have to be called thing to add to. This add function just expects us to pass something in, and then whatever we pass in, it's going to call thing to add to, and it's going to use that variable name throughout its code here. So we can pass in x, we could create a variable that is Tyler, and then pass in Tyler here. It doesn't matter. You can pass in whatever you want, and it'll just change its name to thing to add to while it does this function. So now if we were to come down here, we called add Tyler. Let's print out add Tyler. Okay, so what do you think this is going to do? So we have our function add. It's going to add 1 to the thing that we put into it, and we're putting into it Tyler, which is equal to 10. Do you think this is going to print 11 because we're adding 1 to it? Let's hit run, and then we're going to come and we're going to show you exactly what this outputted by coming down here. And would you look at that? It printed out none. Why did it print out none? Well, that's a very interesting question, isn't it? So the reason this printed out none is because when we go into our function here, let's come back up to our function. When we go into our function, we don't actually return anything. We add 1 here, but then we don't send it back. So what happens if we were to print thing to add to inside of our function? Well, let's run that, and then let's see. Oh, would you look at that? So it's printing 11 because we pass in 10, it adds 1 to it, and then it prints that variable that is 11. But then when it prints add Tyler, it says, I don't know, you didn't return anything from this function. So this is really straightforward. All you have to do is add a return to your function. We'll return thing to add to, and this will now print back whatever this function returns. This is like when we look at our y of x is equal to x squared, we're returning when we put in something, we need to get it back. So we have to return from here, the same as we have to return from here. So now when we run this, we're going to see that it's 2 11s. And I'll show you real quick. I just realized I didn't show you that code actually. Return right here. We're going to return thing to add to, and it'll work out just the way we want it to, printing out 2 11s. So there's a big difference between define thing to add to without a return and then define thing to add to with a return. You got to be careful with that kind of stuff, or else you're going to run into some logical errors that your code is syntactically correct. It compiles, it runs, but it's not going to give you back what you thought your code was going to give back. So pretty important here. Let's move on to something fun. And this is something you may know from Minecraft. Have you ever heard of Turtle? You might have heard of Turtle. I'm going to get at least one person in this video's comment section that knows what Turtle is. And I'm excited for that person to be like, I'm hyped over Turtle. So let's bump the code screen down a little bit here. And let's start doing some stuff with Turtle. Let's actually bring this right back up a little bit just to give ourselves a bit more room on the screen. So Turtle is essentially, in Minecraft, it was a little computer that you could code to do different functions on the screen. And it was legitimately called Turtle, and the programming software that it used was Lua, which many of you know is also what Isaac mods are coded in, but it's also a derivative of Python. Fun fact. So Turtle is also available in Python. Now, we can't mine diamonds or mine coal or do any crafting with turtles in Python, but what we can do is draw pretty pictures. So let's import in Turtle. This is going to import in a library in Python called Turtle, and this is going to include all the functions that we can use for Turtle. So these are all functions. That's the important stuff here. These are already written. We don't have to do anything with them. They're just available for us to use, which is really awesome. So let's do something very basic with the turtle, and then we'll do something a little bit more advanced. So I want to have the turtle speed be 1. So we're going to call turtle dot, and then the name of the function is speed. And we're not going to go into why this is turtle dot. This actually has to do with classes, which can go back to the object-oriented thing. We're not going to talk too much about that right now. Just know that any turtle commands, you have to do turtle dot before. Pretty important. So we're going to put the speed as 1. That's actually the slowest that the turtle can go, just so that you can see everything that comes onto the screen here. We're also going to have, we're going to move the turtle forward. So turtle dot forward. And then we get to pass in a variable here, which is going to be how far it goes forward. Let's just say it goes forward 100. Okay. And then finally, we're going to say, turtle, you're done. Turtle dot done. No anything in the parentheses. Just a very basic thing here. Now, when we run this, and I'm a little bit afraid, yeah, it didn't show up on the screen, which is a small dilemma. Let me real quick add another window here so you can hopefully see what is going on, because it opened up a new window with the turtle stuff going on. So real quick, there we go. So here's our turtle right there, and I'll just be able to do this back and forth. So I'm going to run the code again so you can see exactly what occurs here. Are you kidding me? It only did that one singular turtle window. Give me 1 second. I'll figure out a good way of doing this. Okay, it's a little bit screwy, but it'll work. So when we run this code, it's going to open up a new window, and it's going to draw forward 100 paces. And it always points to the east at the start, and it will start drawing from there. So we move forward 100. We can change this, and we can say move forward 200. And when we run it, he is going to move forward an extra 100 spots. You may have noticed that that was a little bit further than last time. Let's move it forward 300, just so all of you can be satisfied by watching this move forward another 100 spots. There you go. Pretty exciting. Dare I move it forward 400? Let's do it. Moves forward an extra 100 spots from there. Okay, so pretty cool. We can move this turtle forward 400. We can also move it in different cardinal directions. So let's now say turtle dot left. And left is going to change the position of the turtle at some given angle. So we put an angle in here. And there requires a little bit of math here. And if you're a bit younger trying to learn this and you haven't gone through geometry and algebra yet, this is going to be a little bit more difficult for you. But stay with it. 90-degree angle is going to move us from a straight line. So I'm moving my cursor going in a straight line. To then this guy's going to turn and be moving at a 90-degree angle. It's going to turn 90 degrees to the left, which is then going to have it facing up. So we can actually run this, and you will see this guy goes, and then he turns, and he's ready to go up. So what we can essentially do here is then say turtle dot forward, let's go 100, and then turtle dot left again, and we will have him go 90, And then I could say turtle.forward 400, and then turtle.left 90, and then turtle.forward 100, and then we'll just turn him right back to his starting position, as many of you may know exactly what I'm doing right here, because we can now make this turtle draw a little rectangle. So he's going to do exactly what we say, and we have now drawn a little rectangle, and he is back ready to go, which is kind of dope. You can't deny that. So now what do we do? What do we do to make this into a more reusable piece of code? So let's define a main function, okay? And main functions are pretty important in code because they usually contain all of the code that you call during your program. You don't want to just have extraneous functions that you call throughout your code, and many languages won't even let you do this. So you want to have a main function that you then call other pieces of code in. So we'll call main at the very end here. And then what do we want to put inside of our main function? So we're going to create a function called rectangle. Okay, and let's actually take all of this up here and let's just make this be our function. So we're going to go down, we're going to say define rectangle, and we're going to have it pass in a size. Okay, and then we're going to take all this, and since Python needs whitespace, we'll just tab these over so that they're all good and ready to go as so. I'm happy with that. And then we don't want this to be done every time we call a rectangle because we want to reuse this rectangle function. So let's actually call turtle.speed at the very beginning because we don't really need it to call turtle.speed a number of times. We just need it to do it once. So we will call turtle.speed at the start of main. And then we will call rectangle with a size of 100. Now right now this is passing in size here, but we're never using size anywhere in here. So let's use size in here. Instead of hard coding in these numbers here, let's use the size variable. So if size is being passed in as 100, and this was 400 before, let's do size times 4. And that'll work out fine. This was 100, so just do size. This was another 400, so size times 4. And then this was a 100, so we can do size. That's pretty cool. So now we can come over here, we can say rectangle of 100, and then we can run this, and this is going to do the exact same code that we had before, because we really didn't change anything. All we did was make it use a function instead. I'm hoping that that actually showed you that there was a line there. There was indeed a line there on my screen, but I'm looking at OBS and there was not a line there. So the window closed at the end because we didn't put turtle.done here. That'll keep this window open and everything will be pretty. He goes up, he draws, and that line is just totally not appearing in OBS. So it's like very faintly there. I hope it's just a bug on my viewing right now and you can't actually see that. But let's do something funky here. Let's change the size of these rectangles. Okay, so let's make another rectangle that's size 200. Not rectangle. And then let's make another rectangle. And let's make this one size 50 for the hell of it. And then we'll do another even tinier rectangle of size 25. And this is going to create some kind of trippy thing that I'm excited to see here. It's going to go over. It's going to go up. It's going to make our invisible line right here that I hope you can see. And then it's going to start making another rectangle. And this time it's going to be one that's even bigger. Hell, it goes off the page right now. But it will come back. Don't worry. There he is. He came back. And then he's going to go down. And that's just our big rectangle. And now he's going to make a smaller one. Because this is the 50. So now it's going to go in. It's going to do the 50. And now it's going to do the 25. And make an even smaller one. So now we have some nice rectangles that are just growing in size as we go up. My cursor is spazzing out on that image right now, but that is a-okay. Let's do something even funkier. Instead of just having you pass in size, let's also pass in the angle. Okay, so instead of 90, let's make this a little bit different. Let's change these all to be the angle. And instead of going 90 degrees, let's instead pass in the angle down here as negative 90 degrees. Okay, So what is this going to do? This is essentially going to do a rectangle still, but it's going to be the reverse of what we did before. It's going to start going to the other side because we did negative 90. So now it's going to go down, and it's going to make our rectangle this way. And now you can actually see the line, hopefully, at least parts of it. Now it's going to go build the 200. And as you can see, it was very easy to take this function and say we needed to make 700 rectangles. Instead of me taking, I'm going to close this right now. Instead of me taking these lines of code and copy and pasting them 200 times to have all of the rectangles we need, it's much more efficient to call this function just a couple of times. And it works out just the way we want it to. Nice and easy, doing exactly as we would like. I've copy and pasted this way too many times. Holy crap. That is okay though. So as you can see, hopefully if this doesn't show you that functions are important, then you might be a lost cause, because this is a prime use of how functions can be so important in Python. Hopefully this guy's taught you a little bit. We will be using functions all the time in these coding tutorials. So if you have any questions, let me know in the comment section down below. On Sunday, we will be using functions to make our very own calculator. And I'm going to show you guys how to make a calculator in Python that is fully usable and will punch out any answer to a basic math equation that you put into it. So that'll be pretty cool. All using functions. Once again, any questions, let me know in the comments down below, or join the Discord and ask questions there as well. Thank you so much for watching. I'll see you guys in the next video. Bye.